Assalamu alaikum, everyone. Welcome to Mathematics with Shahab Yaqub. We are starting this S2 lecture, and it's about sampling and estimation. Now, earlier, we have talked about the distribution of sample mean, that X bar, this is known as the sample mean. It follows a normal distribution. Mu is the mean, and sigma square is now divided by n, where n is the number of samples. Earlier, our z was x minus mu over sigma. Instead of sigma square, we take the square root of sigma square, which becomes sigma. So now what is the new variance? The new variance is sigma square over n. So therefore, we take the square root of sigma square over n, which becomes sigma over root n. Now, if someone asks for the mean and variance for this, so expectation of x bar is mu and variance of x bar is sigma square over n. Now, we talked about all these things. We did some questions. Maybe those questions were different. This is different. Basically, now we have to focus on back solving. That means we will use the probability to find the corresponding z value, to find the value of x. Rule number one, make sure probability is at least 0.5. This is from S1. If not, subtract probability from 1 and flip the inequality. For example, probability z lesser than a is 90%. This is more than 0.5. There is a lesser sign, z value is positive, and the corresponding z value to 90% is 1.282. That is from the strip. Something like this. Probability x lesser than a is 0.05, and x follows a normal distribution 200, 100. So now, first of all, since this is only 5%, 0.05 is 5%, this is lesser than 50%. So what do? We subtract the probability from 1 and flip the inequality. So lesser becomes greater. It's x right now. It will be converted to z. The greater sign will remain as it is. That means the corresponding z value is negative. And then we do comparing coefficient. So now let's apply this knowledge in these questions related to back solving and central limit theorem. So this is the table that I'm talking about. These are the commonly used 9 values that we come across. Actually, the first 6 values are the most common one. These 3 and these 3, these are the most common one. So this value is 75%, this value is 90%, this is 95%. This is 97.5%, this is 99%, this is 99.5%. And these are the corresponding z values that we will be using. So these 6 z values will be in use. Now, for example, look at this question. It says a machine dispenses tea, x amount, tea in amounts x ml. So this is tea, and the amount is in milliliters, where x follows a normal distribution 60, 12. An independent sample of size 20 is taken. For what value of k can we be 95% sure or certain that the sample mean will exceed k? Now, the first thing that needs to be done, x follows a normal distribution 60, 12. Let's put an x bar over here because it's a sample mean question. It says over here, and the sample size is 20, so this 12 is divided by 20. The second thing that needs to be done, that is translate this equation, which is sample mean will exceed. Exceed means greater than k, and this probability is 95%. So probability x bar greater than k is 0.95. Probability z greater than k minus 60 over 12 over 20 square root is equals to 0.95. Now, let's go to the table. Z greater than a particular value is 0.95. For 95%, this is the corresponding z value, 1.645. So this is 1.645, but because there is a greater sign over here, therefore z value is negative. So now let's compare coefficient. So we are comparing this thing, which is k minus 60 over this thing square root equals to negative 1.645. So therefore, k minus 60 divided by square root of 12 over 20 equals to negative 1.645. Therefore, k is equals to 60 plus negative 1.645 into square root 12 over 20. We use a calculator and then we get the answer. All good, all clear? So now let's look at this question. Why don't you people go ahead and try it out? Let me pause the recording. So now let's look at this question. It says the time x minutes a mechanic should take to mend a puncture is such that x follows a normal distribution 25,8. The mechanic is timed over 20 occasions and the mean time is taken. Find the time m minutes for which we can be 99% sure that the mean time will be less than m. So first of all, we will write x bar follows a normal distribution 25,8 divided by 20, where 20 is the number of sample. It's about sample mean because it says mean time. Now it says probability x bar lesser than m is 0.99. Probability z is lesser than m minus 25 over 8 over 20 square root is 0.99. Probability z lesser than some value is 0.99. What is this value corresponding to 0.99? That is 2.326, 2.326. And since the sign is lesser, after making sure the probability is at least 50%, therefore this value is positive. Comparing coefficient, m minus 25 over 8 over 20 square root is equals to positive 2.326. M is equals to 25 plus 2.326 multiplying with 8 over 20 square root. And this answer is written right over here. That is 26.5, correct to 3 significant figures. Now let's look at a past paper question. And it will be about the previous thing. That is the distribution of sample mean. Now the question says that a clock contains 4 new batteries, each of which gives a voltage which is normally distributed with mean 1.54 and standard deviation 0.05. The voltages of the batteries are independent. The clock will only work if the total voltage is greater than 5.95. First part, find the probability the clock will work. The first part is about linear combination because it's talking about the total. So the first part is about linear combination. So let me work on the linear combination part first. So first of all, it's about voltage. So voltage follows a normal distribution 1.54, 0.05 square. We are talking about 4 batteries. So we will say X is equals to battery 1, battery 2, battery 3 plus battery 4. So now expectation of X, I can write it this way also. That is 4 times 1.54. And variance of X, it's not a question of multiple. So it's also 4 times 0.05 square. I can even write it like this. X follows a normal distribution 4 times 1.54, 4 times 0.05 square. Now it says find the probability the clock will work. The clock will work when the voltage is greater than 5.95. So probability X is greater than 5.95. Keep in mind, it's not a sampling question. Probability Z is greater than 5.95 minus 4 times 1.54 divided by square root of 4 times 0.05 square. And then you get this particular answer. So probability Z is greater than some value. You apply the rule and then you get this particular probability. Is this part all good, all clear? Okay. Everyone have a good look at it. So now let me go to the second part. The first is linear combination. Now what is the second part? And also I'll be needing the values for this because I'll be using the same thing over here. X follows the normal distribution. What is 4 times 1.54? 6.16. And what is 4 times 0.05 square? 0.01. 0.01. That is the overall mean. Now, let's look at this part. It says find the probability, the average total voltage. It's kind of a contradiction kind of thing. They're talking about total, but they're talking about average. That means they are talking about the mean total average of the batteries of 20 clocks chosen at random exceeds 6.2 volts. That means we took this thing from there. We will put in X bar. We would divide by what? We would divide by 20. So the total thing is taken, but we are doing sampling of that total. So therefore, probability X bar is greater than 6.2. And naturally, also think about this practically. These values over here, they should be very close by. It cannot happen that you can have a big value of 20 times 60.16. That is not possible. This is kind of, the Z value would be a very, very big value. So naturally, this value and this X bar value should be very close to one another. So now we would say probability Z is greater than 6.2 minus 6.16 divided by 0.01 divided by 20 square root, and then knowledge of S1 is assumed, and you will find the probability. So a single question in which the concept of both linear combination and sampling was asked for. First part was linear combination. The second part was sampling. So now let me just give you the mark scheme for this one. Question number 5. And this is this chapter. Question 5, that is over here. And let me also show you the alternative way that they have done. It's another matter that I don't agree with that working. Now, first of all, look at the first part. That is what we have already done. That is this thing, 1.54 is multiplying with 4. And this variance is multiplying with 4. That is 6.16 and 0.01. Probability total is greater than 5.95. You apply and then you get this answer. The second part, the average, 6.16, that's right over here. And 0.01, that's right over here. And this thing is divided by 20, where 20 is the number of sample. So instead of average, we should write like X bar. Probability X bar is greater than 6.2. We did all this working, and our working is up till here. So far, so good. This is all perfect. So this is all good. This is all good. This is all good. Now, this is the alternative working. What they have done is that, how do you think they got this value and this value? Multiplied by 20. So what they did was they wrote that X follows a normal distribution, not X bar, the original 6.16, and this is 0.01, right? 0.01 or 10? 0.01. Yahan pe, over here, this is 6.16, this is 0.01. They multiplied it by 20. They multiplied it by 20. They are considering it as the total. And they are considering that 6.2 into 20, that is coming out to be 124. So they were working in total. I disagree with this. The reason being, it's a sampling question. Let it remain a sampling question. As simple as this. Okay, now, another question. It says the masses of cornflakes are normally distributed. Now, this is already normal distribution with standard deviation 11 grams. A random sample of 20 packets was weighed and found to have a mean mass of 746 grams. So this is about mass of packets of cornflakes. Given that the population mean is actually 750, find the smallest possible size n for which it is at least 95% certain that the mean mass of the sample exceeds 745 grams. So now let me give you the hint. I would like you to try it out. This is a question of back solving. That's the first thing. And what data you need to use, think about it and try it out. Let me pause the recording. So let's solve this particular question. Now, first of all, we know that it's a sampling question. For sampling question, we need two things. X bar follows a normal distribution. We need a mu. We need a sigma square over n. We need a z value, which is x bar minus mu sigma square over n under root. First of all, what I'll do is that I'll go to the main table, and for 97%, I'll get the corresponding z value. It comes out to be 1.881. It can also be written as 1.882. Two options are there, both are correct. The second thing is that I need to identify what goes where. So first of all, we have a standard deviation of 11 grams that will go over here with the square. The second thing is this n, smallest possible sample size n. So this n will go over here. Actually, variance divided by n. Then the third thing is that we have this thing, which is the mean, the mu. So the population mean mass is actually 750. So this 750 will go over here. So let me write it out. This is 750. And this value over here is 11. So this is 11 square. And then we have n that goes over here. Now, what is the 746? So 746 is the mean mass, and we will be working with this. So x bar value is 746. So now this 20 is not used because we are finding the corresponding value of n. The mean based upon those 20 was 746. We have to use that. So therefore 1.881. And now the question is, will we take the positive value or the negative value? Let me first write it down, and then I'll just tell you which one is the right one. So this is 746 minus mu, which is 750. Now, since this value 746 is less than 750, that means the numerator is negative. In order to balance it, it should be a negative sign on the other side also. When the z value is negative, that means x bar is lesser than mu, and then we will divide by 11 square over n square root. Let's simplify it a bit more. 1.881 into 11 divided by root n. I've cross multiplied. That is 746 minus 750, which comes out to be -4. The negative cancels out. And then we have 1.881 into 11 divided by 4 is equals to square root of n, and hence you will find the value of it. Okay, let's double check. 1.881 with a negative sign, 746. 746 or 745? 745, my bad. So 745 is there. So let me just correct myself. So that is 745, therefore this is 5. Okay, so that 20 value has a mean of 746, but we are looking for 745. So this is 745, this is -5, this is 5 over here, and then you'll find the value of it. All good, all clear? Okay. It says the masses of packets of cornflakes are normally distributed. This is the standard deviation. Random sample gave the mean mass as 746. That is something separate. Given that the population mean mass is actually 750, so 750 goes over here. Standard deviation goes over here. Find the smallest possible sample size, so n goes over here, for which it is at least 97% certain that the mean mass of the sample exceeds 745. Now, I did not write the inequality as such. Basically, it is probability x bar greater than 745. This equals to at least 97%. So greater than or equal to 97%. Since we are looking for the smallest sample size, naturally we have to work for 97%. So now when we will standardize this, z is 745 minus 750 divided by 11 square over n square root, and then we compare it with this. Info, maybe that was given for some other parts. Maybe there is a possibility. Maybe there was some other part. That is the reason. Okay, so now this thing is done. Now let's talk about central limit theorem.